Hello and welcome to UnZOOsual Careers, where we explore the variety of careers in science, technology, engineering, arts, and math at the Smithsonian's National Zoo and Conservation Biology Institute. My name is Shelley, my pronouns are she, her, hers, and I'll be your host for today. Before we meet our guest for today, I'm going to take a minute to go over the format of today's program. This webinar is live captioned. You'll want to locate that CC button at the bottom of your screen for those to appear. You'll also notice that this program is being interpreted in American Sign Language. This feature is best viewed from a desktop computer rather than a tablet or phone. If you are having trouble with either of these services, please chat us so we can assist you. Remember, this is a webinar, so we cannot see or hear you. However, we encourage you to engage with us in a number of ways. You already saw that we'll be launching polls throughout the program. Additionally, you'll see that the Q&A is open. Please use the Q&A at any time to ask questions of our guest. Try to keep your questions on topic, and you can check under the My Questions column to see if your question was already answered. Educators, if you're streaming for your whole class, be sure to chime in on their behalf. Today's program will be about 45 minutes with an additional 15 minutes at the end for a live Q&A where we will answer as many of your questions as time will allow. Lastly, you'll see that the chat is open for you to message us. I do want to take a minute to quickly introduce my team who's helping behind the scenes. Today we have Erica, Kaden, and Emily also answering your questions. And we also have a very special chat expert, Rick Quintero, curator of water quality, life support systems in Amazonia. So you may see some responses from him in the chat and Q&A as well. So once again, everyone, welcome to UnZOOsual Careers. I am so thrilled to welcome Jalal Abdo to today's program. Hi, Jalal, welcome.
Hi, Shelley. Thanks for having me. How are you doing today?
I'm doing well. Why don't you start by telling us what it is you do for the zoo?
Shelley, actually, I am an aquatic life support systems operator here at the National Zoo.
All right, that's a pretty long title. I know the word aquatic means water. So what exactly are you operating?
I actually operate and maintain all the systems and machines that filter and clean water for the animals in the zoo that live in an aquatic environment. I basically ensure that the water habitats are safe for these animals.
Wow, okay, so there are so many aquatic animals here at the zoo. We're seeing some on the screen. Viewers, think about, put in the chat what your favorite aquatic animal is. So I'm seeing corals and sea lions and seals. You're working to keep all of these water habitats safe?
Yes, I work to keep the water habitat safe for, just like you said, the seals, sea lions, river otters, fish, coral, amphibians, and more.
But I'm a little confused because from what I know about all of these animals, the seals and the sea lions, they're living in an ocean environment. River otters are living in rivers. We have freshwater and saltwater fish. Some amphibians are found in streams and ponds. So even though these are all aquatic or water environments, they're all very different.
You hit the nail on the head, absolutely. Each animal has its own requirements and they have different needs. We have everything from, like the seals and the sea lions that require ocean salt water to, our Amazonia exhibits that require water that's, a little more acidic and fresh water.
Yeah, that's really cool. So that's amazing that you have to kind of know all these differences between the individual animals and their water requirements. So how do you know what the animal's water needs are? Are you going to these habitats in the wild to collect samples and look at all of the factors? Are you traveling to, say, Monterey, California to look at the water of the sea lion?
Not exactly. We do have a lot of published natural history information that we can, rely on to see what the parameters needed for each species. Now, if the information is not available, then yes, we will rely on somehow getting a hold of the information, whether we travel there ourselves or contact colleagues that are already out on the field to collect the samples for us.
Okay, got it. So you're trying to recreate the same water that we're seeing in the wild, but in the National Zoo.
Yes.
Great. All right. So this seems like it might be a little bit complicated. It seems like, in these wild systems, there are a lot of other things going on, but here in the middle of Washington, D.C., where the National Zoo is, we seem to be limited kind of by space. We don't have a giant ocean for our animals.
True. Space is a limiting factor. We provide our animals with whatever space is required to allow them to thrive in captivity. For example, their sea lions exhibit is roughly 500,000 gallons. The average bathtub, just to put it into comparison, is about 50 gallons. I mean,
oh, wow.
Yeah, it very limits having a sea lion as a pet. You won't have the space for it otherwise.
Absolutely. So for all of you watching, yes, a sea lion would probably not make a good pet because your bathtub doesn't hold 500,000 gallons. That's wonderful. So besides space, I know that there are a lot of other factors when it comes to water quality that you have to take into consideration when trying to replicate these wild systems. So I'm going to launch another poll for our audience here. What other factors does Jalal consider for water quality? These are select all that apply. Do you think poop, pH, salts, and or bacteria? So I'll give you a couple seconds on that poll. And let's see. Oh, we had some other answers in the chat too. Some other people's favorite aquatic animals were otters, whales. Lorelei specifically said macroinvertebrates and sharks. That is so fascinating and a great example. All right, I am going to give you another 5, 4, 3, 2, 1 on that poll. Let's see what folks said. I will share these results. All right, Jalal, it looks like our answers are pretty evenly split amongst the 4 factors that you consider. Which of these is correct?
Actually, all of them, and even more.
Yeah, I'm sure.
Yeah, absolutely. I mean, we use city water to try to, we have to use city water, which is safe for people, because they treat the water for humans to be able to consume, but it is not necessarily safe for all animals. Some chemicals like chlorine and chloramines are not safe for fish and amphibians, so we retreat the water to help make it safer.
That's amazing. So let's start with probably everyone's favorite topic. Let's talk about poop. With aquatic animals means animals pooping in water.
Yeah.
How do we deal with that in a zoo setting?
Well, let's first explain how it is in a wildlife setting. You have your nitrogen cycle, just to kind of quick overview, your fecal matter, your poop, gets decomposed, producing ammonia, and then you have 2 stages of nitrifying bacteria that turn it into nitrites and nitrates. Out of those 3, ammonia and nitrites are very toxic for fish and amphibians and such. The nitrates, not so much unless you get into high quantities. But luckily, nature has its own filtration system, whether it be rainfall, river flowing, temperature changes, sunlight, so on and so forth. Here at the zoo, we try to recreate kind of the same thing that nature does. The nitrogen cycle is always a must. We try to get that going properly, and then using backwashing and other things to recreate the weather and what nature does.
Right. So there's all these chemical reactions, really, biological reactions that happen in a wild water system that will naturally take care of poop and other things that are happening. So you're not only recreating the water, but you're recreating the water systems. So that's why your title is Aquatic Life Support systems. It's the whole system we're recreating, not just the water. That's fantastic. So we do have a question here in the Q&A already about, again, that poop. How do we solve this poop problem in a zoo when we can't perfectly recreate those nitrite systems that you were talking about, the nitrogen systems, the rainfall, the temperature, all of those things affect it. So how do we do that here in the zoo?
Oh, I'm glad you asked. It's a fun little thing that we do. It's we poop dive.
Poop dive, okay.
Absolutely. Put on a wetsuit, jump in the exhibits with a big vacuum, kind of like cleaning a room, just picking them up and then getting them out of the exhibits. So that way, see, there's an example right there. It's all be in there, cleaning, getting all the poop out.
That's real. Yeah, absolutely. This is probably one of the most unusual career or job duties that we've heard on this series is poop diving. Now, is this something that you had to train for? This is a certification to be able to dive in the water like this, correct?
The diving in water, especially working, at the Smithsonian, they want you, to be very careful. Yes, I was lucky enough to be able to go to Panama to get my dive certification. Even though, but we still need all the people, numerous people to be able to scuba dive. So you'll see most times I'm actually more snorkeling than scuba diving. So that way, we can use kind of less people to make it more efficient.
Yeah, that's really cool. And we have somebody in the chat who said that their mom makes them vacuum, which, yes, we all have to do it. This just looks a little bit different. I didn't know that you could vacuum in the water. So this is a great video. Let's
imagine vacuuming poop in the water.
Yeah. Let's see. So this video, I think you were just actually cleaning the glass, which, again, using that diving certificate. There you go. What are those little black things in your hand in this video?
Suction cups.
Oh.
Because the cleaning the windows requires a little elbow grease. And when you're underwater, pushing against glass, with trying to scrape it off, doesn't always work. So you need to have an opposing force, like me pulling against it, to kind of keep the leverage going to be able to scrape off the algae that grows on it, the algae blooms.
That's a fun, great little example of little using our innovation to solve some problems in the water. That's great. Oh yeah, there you go. All right. What a fun duty assigned in your career. So we saw in our poll, as you mentioned, that there are all these other factors that you have to pay attention to with water quality. What are some of the ones that you talk about with this bacteria? How do you take care of and test for bacteria in your different water systems?
How do we test for bacteria? To take care of the bacteria, different systems do different things. For example, in Amazonia, we have a more biologically active system that use aerobic bacteria to break down organic waste to make it into non-toxic byproducts. Here in Amazonia, it's us as well as the animal keepers. We kind of act like Mother Nature would to replace water, whether it be backwashing, water changes, versus what Mother Nature does using like rainstorms and weather events to help control the amount of whether it be beneficial bacteria, like your nitrifying bacteria, or your harmful bacteria.
Wow. So again, we're not trying to rid all of the water of bacteria like maybe we would for drinking water, but we want some good bacteria growing in our freshwater systems because that will help to clean the water and actually break it down.
Yeah.
So once again, it's taking care of the whole system by promoting that aerobic bacteria that you talked about. But again, the needs that you just talked about in Amazonia might not be the same water quality needs that, say, our seals and sea lions, also called pinnipeds, might need, correct?
Yeah, pinnipeds are seals and sea lions, correct.
So what kind of things do you require? I mean, I know seals and sea lions, we probably don't want the same types of bacteria growing in the saltwater pools.
Over at the pinniped pools, we use more of a chemical treated system because you don't want, again, the harmful bacteria growth in the pinniped pools. So yeah, we have the option of using different chemicals and using UV sterilization to treat these pools.
Okay, and I think many of our viewers have probably gone swimming in chlorinated pools, or if you've been to outdoor pools, they're usually treated with chlorine. So again, it doesn't have that harmful bacteria in it. But from what we've talked about, I heard that the zoo field as a whole is moving away from some of this chemical cleaning and using another gas that I think our viewers have probably heard of to clean the water, and that's ozone. So I want our viewers at home, if you have heard of the word ozone before, put in the chat where you've heard this word, in what context. And let's see. Yes, so someone said the ozone layer in the sky. Absolutely. The ozone layer, yes. You are absolutely hitting it. So when we have historically heard of ozone, ozone is a gas that's in our atmosphere. It's brought up a lot when it talk about climate change. So how do you use ozone to clean water for our pinnipeds, our seals, and our sea lions?
Ozone is actually a very strong oxidizer. If you don't know what ozone is, you hear about the ozone layer. Just like regular air that you breathe has O2, which is what everybody knows. Ozone is 3 parts oxygen rather than 2 parts oxygen, which makes it, makes it very active. So we use that and inject it in our system because it is a strong oxidizer, it attacks the cell walls of all living cells, like bacteria and algae, so on and so forth. That's why we use it in our water for disinfection. But you also have to be very safe with it because, we want to keep it away from the animals, which is why we use it in a sort of secondary system from our regular filtration system. By that, I mean, while it's going through the filtration system, we pull some of it out, inject it with ozone. Now your water is just, full of ozone, attacking bacteria. And then when it's done doing that, we take out all the ozone again by just agitating it. An example that my boss told me that I love is imagine a soda bottle. You shake it a lot, and then open it, what happens? All the gas wants to explode out of it. And that's basically what we do to remove all the ozone out of the water before introducing it back into the animals, because we don't want the ozone with the animals. So we shake it up, get all the ozone out, and then return the clean water back into the exhibit.
That's really, really cool. And some people are commenting in the chat too. It is a very highly reactive gas. So just such a cool way, potentially dangerous, but you are so trained to deal with this gas. Yes. And then also trained to monitor, maintain, test, and fix these ozone injection systems. That's really, really neat. And I just want to sort of reiterate, as we've been talking about this, that we have multiple systems at the zoo, as we were talking about those biologically active systems that we're recreating with the aerobic bacteria to clean. And then we have the chemically treated systems at the zoo, which is what we're talking about now, where we are cleaning the water of bacteria, and in this case, using these ozone generators. That was a great example of opening a soda can. I loved that. Great. So we talked about poop. We've talked about bacteria and how we clean the water. There's another sort of big aspect to especially those seal and sea lion pools. You're recreating ocean water, which from my experience is rather salty. How do you replicate salt water for our animals? And I'm going to launch another poll here. We mentioned that the sea lion pool is almost 500,000 gallons large. Looks like my polls are taking just a second. So I'm going to be asking you, how many tons of salt are in the 425,000 gallon sea lion pool? Let's see if I can launch this. There we go. Do you think 1 ton of salt goes in this pool, 10 tons, 40 tons, or 60 tons? I'll give you a few seconds on that.
I have a guess.
What are you guessing?
I'm gonna spoil it.
All right. All right, folks, I will give you another 5, 4, 3, 2, 1. I will end this poll. Let's share these results. All right, Jalal, it looks like the majority of folks believe that 40 tons of salt go into the 425,000 gallon sea lion pool, followed by 60 tons. How much salt is going into these pools?
60 tons is correct.
60 tons of salt.
60 tons. Yeah, if you look at that picture, that is 1 ton of salt right there. So if we were to completely drain the sea lion exhibit and then fill it back up to get it to proper salinity, we need 60 of those bags. That's a lot of salt.
That's so much salt.
That is a lot of salt. Which is why we incorporated a backwash recovery system for our pennypack pools to save the salinity. You know, when we backwash our filters daily on those pools, we are backwashing about 15,000 gallons of water a day. Now, if we were to just dump all that water and then refill it and then try to bring the salinity back to where it needs to be, we would need an average of 2 tons of salt a day. I mean, we already spoke about the limiting space for what we have in the zoo. Imagine keeping 50 plus bags of salt, tons of salt. We won't have any critics, absolutely.
No, I was going to say 2 tons a day is a huge number. I don't know where in the zoo we would begin to keep that. Alice agreed that, oh my goodness, 60 tons, that is absolutely a lot of salt. You've mentioned this word backwash a couple times. Can you just break down what it means when you say the word backwash?
Backwashing is clearing the filtration system. So, you know, the way, let's say, give a sand filter as an example. The way it works is, you know, you have water coming in from the top, and then it filters through the sand, you know, taking out all the waste, and then, you know, coming out the bottom. Now all that waste is collected in the filters. Backwashing, what we're doing is reversing the flow, reversing the flow of the water, opening up, you know, closing where it came from, opening up a different valve for it to go out to waste, but in the sea lion exhibit, going into a backwash recovery system to remove all the waste that was collected, to keep the filtration system nice and clear.
That's great. And I think we're seeing an example of one of these backwash systems that you and the team monitor via computers, which is fantastic. And I do just want to reiterate again, with this backwashing system, it's what allows us to conserve so much water and to conserve all of that 60-ton salt that we put in these pools, so that we don't have to constantly, like you said, add 2 tons of salt every single day. That's great. So you mentioned a lot of these other tests that you're constantly running. What are some of these other things that you test for on your day-to-day basis in these water systems?
We test for the pH of the water. We test for ammonia. We test for turbidity. We test for, sometimes phosphates, nitrates, so on and so forth. We have different machines, some advanced like our spectrophotometers and turbidimeters, and some that are a little more simple, like our coloration pH test kit, and refractometer.
That's really, really neat. I do want to touch on pH. Can you briefly tell us what exactly when we test for pH, what does that measure in the water?
Percent hydrogen in the water.
Percent hydrogen. Okay.
Yeah, hopefully I didn't mess that up. But yeah, that lets you know whether the water is neutral or it's more basic or acidic.
Great. So we actually have a photo of a real pH test that you have done, and we're going to launch another poll here. Let's give our viewers a chance to read this pH test. I want you to read this test, and what we're doing is we're matching this tube of water on the left, the color of it, to the legend on the right side with these numbers. So what is the pH of this water? 6.8, 7.0, 7.2, 7.4, and 7.6. So the legend is various shades, with 6.8 being yellow and 7.6 being pink, and all the shades in between. So we're looking to match those. And this is how we test the pH of water. All right. Give you another few seconds on that poll. I also like salt, Rosalind, and some other viewers. I am also a salt person over sweet. That's great. All right, we'll close this poll in 5, 4, 3, 2, 1. Let's see what folks thought. All right, it looks like the majority thought maybe about 7.2, followed by 7.4. What would you say the pH of this water sample is, Jalal?
I would probably say between the two, 7.4 to 7.2. I would probably say closer to 7.4, but not everybody sees color differently. Yeah.
Great.
I think it was closer to that.
And what number are we looking for the water to be?
That is a good question. It depends. See, so we have to find out where the sample came from. So, for example, if it came from the electric eel exhibit, you want it to be a little more acidic. If it came from the seal or sea line exhibit, you want it to be more alkaline, more basic, like ocean water would be. For this example, let's just say it came from the seal or sea line exhibit. We want that to be closer to about, a little over 8 pH. So to bring it up to that, we have to use chemicals. In this case, we would use carbonates and bicarbonates to bring up the pH of the water. Now, a second factor that you also have to put into play, and this is where math comes into play, is that you have to find out the volume of water the sample came from. Because you don't want to just haphazardly throw a bunch of chemicals in water and completely spike it up.
That's great. So can you just clarify for us, we have this number scale, which is more acidic and which is more basic? Is the higher number more acidic?
No, the opposite. The lower number is acidic. Yeah, the number is the more basic it is.
Great.
The more alkaline, yeah.
All right, I think we have another test. Let's try again on our second photo of pH test here. All right, let's launch this poll. What do you think is the pH of this water sample? All right, again, 6.8, 7.0, 7.2, 7.4, or 7.6. Does look a little bit different in this one. All right, close this poll in 5, 4, 3, 2, and 1. All right, I think most people here guessed 7.6. What would you say, Jalal?
It's a little unfair. It's actually a little higher, but the number scale was kind of off the screen.
Okay.
Like a 7.8 or 7.9.
Wow. Okay. So again, these are just two separate water tests from two separate systems in the zoo. That's great. All right, and you had talked about the refractometer. What is that measuring?
The refractometer, that measures the salinity of the water that you're testing.
So that's going to be super important for those saltwater systems with our pinnipeds, our seals, and our sea lions. That's great. And can you tell us a little bit about these tests that we're seeing here on screen? What are those reading right now?
The one on the left is actually just the city water. We're using that as a base to make sure that the refractometer is calibrated properly. So you'll notice that blue line right across the bottom is at 0, which is what you wanted to see. The one on the right is one of the pinniped pools. And what would you guess it to be? Looks about 30 right there.
Yeah.
Yeah.
So if this test came back that the salt was too low, that's when you would maybe need to bring in one of those one-ton bags of salt to resalt the pool?
Depending on where it is, absolutely. If it was one of the holding pools, half a ton to a ton might be okay. If it was very low on, let's say, the sea lion exhibit, we would need a little more than a ton.
Yeah, that's great. So we have talked about so many of these different tests that you run every day, these different systems, the bacteria systems, this is the chemically treated systems. Mm-hmm. And again, you are operating all of these different systems with thousands and thousands of gallons of water. But where exactly is this taking place in the zoo?
Oh, don't look behind the curtain on your house. It is hidden, and that's what I actually kind of like. If you ever come up to the seal and sea lion exhibit, it's all behind the scenes. You're not going to ever notice it walking up to the building. So, for example, here's a picture of what looks like a shack where the seal and sea lion exhibit is. It looks like a story and a half. But once you go inside, this 1.5 looking building is about 5 stories.
Wow.
Exactly. It's you have your main floor, you have 3 sub-basements. Yeah, this is going in. This is that's my dive suite right there. Here's some of the filtration system on the first floor. Here you have first level basement. And you see these blue tanks? Those, yeah. You average about 500 gallons a minute. And we have about 12 of those on different floors, in our building. I'm looking to see what else you have. Here's another part. These are the pumps that actually just handle the filtration for our holding pools. That's again on just one floor. And we have several other floors. That's the bottom basement. These are for the exhibits. There is, so many different floors that you just will never see behind the scenes. It's kind of like a secret.
It is.
Yeah, a fun little fact, in a 24-hour period, this building will process 10 to 11 million gallons of water.
10 to 11 million gallons of water
Correct.
Get processed every 24 hours in this one building that you just showed us?
Correct. And this is what you see versus what we just showed you.
Again, just not only are we getting this awesome behind the scenes shot of an area that I've never been into, and I've worked at the zoo for 7 years now, but day to day that the zoo is closed. This has just been so neat to be able to see that behind the scenes and have no idea that so much is happening back there with all of these different water systems. But as we saw from one of your previous pictures, like, yes, there's a lot of the pumps and the valves and the testing, but you're doing a lot of work actually from your computer too, that you can monitor the systems from there.
Absolutely. Yeah, I'm definitely lucky to have the technology here that lets me access a lot of these filtration systems. Like all these little circles that you see are all valves that I can manually open and close with a press of a button, from my computer. So it's a completely automated system. So technology has come a long way from where you have to manually do, all, the filtration in these buildings. Here's an example of one of the pump controls. Instead of going down, flipping a breaker, and then manually, starting it, just press a button, and get it started in the comfort of kind of like what I'm doing right now, in front of a shark. It makes it a lot easier. Technology has definitely come a long way.
Well, I was going to say, we asked in one of our original polls what areas of STEAM, science, technology, engineering, arts, and math that our viewers think you use. And 89% said science, followed by 62% said engineering. It's so clear that you're using, we talked about the math that you're using to find the volume of water and salt, the chemistry of all of the chemicals that you're putting in and taking out, and ozone. So I'm just so excited that you are here to talk about your career in STEAM. Thank you so much.
Absolutely.
And I do want to pivot now to talking about how you got here. How did you find this career?
Looking for it. About 4 years ago, because I worked a lot of, retail. I actually have a background in as an electrician's apprentice. So I've worked, different fields in the past. But I just wanted to kind of find something that I could take pride in what I do. Not just go in, work a regular 9 to 5, and go home miserable just for a paycheck. I wanted to feel accomplished, like I was making some sort of difference. I was interested in this position. And again, at this point, it's about 4.5 years ago, started volunteering for several months to see if this position is something that I would be interested in. And it definitely tugged on my heartstrings. I loved everything about what the job entails.
I think that's a common thing that a lot of people are finding in zoo careers. A lot of people start as volunteers and fall in love with the zoo or fall in love with the job just so quickly. And we even have somebody in the chat, Lauren, said that this is a really cool career and would like to do this, which is so fantastic to hear.
Oh, absolutely.
So thinking back to, where our viewers currently are in their school, maybe elementary or middle school, what were you interested in when you were their age?
I was always a big fan of taking things apart and figuring out how they worked, which is why I first started with engineering. But also, I kind of do have a bit of an artistic background and, love computers and applications. And I try to combine both by studying computer animation. That's where I started off in school. Back then, that's what I was interested in. I wish I would have known this existed back then. I would have tailored my studies accordingly.
Yeah, well, it sounds like this sort of combined that engineering and computers quite perfectly for you. So this next question I have for you, I actually want our audience to answer as well. So put it in the chat. Audience, what part of Jalal's job that you've heard about today are you most interested in? Put it in the chat. Maybe it's all the chemistry or the computer engineering or the scuba diving and problem solving. And Jalal, what is your favorite part of your job?
It's several. It's just several things. I love working with my hands, and being able to work on computers. The fact that, we sit here and try to problem solve things with different perspective. Like instead of, if let's say a pump goes wrong, it's just like, oh, let's just fix it. No, we also put into consideration how this will affect, the animals themselves. So, we have a different spark for getting things done. Not gonna lie, walking through the exhibits and, seeing like kids interact with the animals, being able to see them, in my mind, I'm singing, Maui, you're welcome. Well, sometimes out loud too. It's a catchy song.
Yes.
But yeah, love it.
That's fantastic. And our viewers at home, or if they're in school or in class, are saying the exact same thing. Sophia, the problem solving, Killian said being with the animals, scuba diving, problem solving. Natalie's very interested in engineering. So again, all of those same sort of bits about your job that they're interested in too. And again, bringing it home to the reason the zoo is here, our mission to save species. And by you monitoring and maintaining all of these water systems to make our aquatic animals happy and healthy is so vital to the zoo. So we're just so happy again that you are here. Before we move on to our Q&A, I do want to ask, what is the most unusual problem that you have solved in your job?
Oh, we had to build a jump barrier for one of the sea lions. The little catalina wanted to test her limits.
Okay, so you said jump barrier.
Yeah,
you said jump barrier.
I'm sorry?
You said jump barrier, but I don't think of sea lions jumping on land, but this looks like she's jumping out of the water.
She is jumping out of the water. They can jump very high. And you see how close to the top she's there. She can even jump higher than that. So we built a jump barrier over here at the split view window so Catalina does not escape.
That is quite an unusual problem to solve. So you can see from this picture, there it is from the public side, that this little barrier was originally open that she realized she could actually reach. So just another one of those problems to keep folks, zoo staff on their toes. And that's a great other duty as assigned, as we like to call them. Lauren said that she could see many others doing that. Absolutely. So we have reached our 45 minutes. So some folks may need to go if your class is ending. So I am going to launch just our final poll here before we move on to our Q&A. So how did you feel about today's program? Loved it, liked it, it was okay, not for me. And this program left you feeling connected to the zoo, inspired to save species, excited about STEAM careers, and curious about zoo careers. So I am so excited. We have so many great questions coming in. Remember to keep putting them in the Q&A. So Jalal, we had a question here of how hard is it to isolate water systems at the zoo?
To isolate them? It's pretty much a closed system, so they are pretty isolated. I'm not exactly sure how to best answer that.
That's great. How do you handle managing invasive species that get into your controlled environments, especially the ones outside? That's such a great thing to think about. In an ecosystem, invasive species can have huge effects on the ecosystem. So how do we deal with invasive species potentially getting into our closed systems in the zoo? Or do we not have that problem?
I personally don't specifically deal with that problem. That is something that is more dealt on the animal keeper side, because they more directly deal with the animals themselves.
Great. So it would be more of an animal keeper's like, hey, we noticed this fish that's not one of our collection fish in this pool.
Yeah, I mean, it's kind of difficult for a random fish to end up in a closed exhibit.
Right. We had another great question. Alex and Andrew asked, how do you stop bad bacteria from going to a connected tank?
Again, that's where the chemical filtration comes into play, because any bad bacteria is usually suspended in the water, not like the beneficial bacteria, which is more attached to surfaces. So using our chemical treatment attacks those harmful bacteria directly. Whether it's using chlorine, which we don't really use, or ozone, or even UV sterilization, which doesn't necessarily kill the bacteria, but sterilizes them so that way they cannot reproduce, kind of extinguishing them out.
Very cool. And again, some of these other factors that influence wild systems, how do we deal with them? Killian asked, does the water ever freeze? Our pools, the seal or sea lion pools, ever freeze being outside?
In the 4 years that I've been here, I have not dealt with that specifically, because especially the systems that I work on are actually temperature controlled. We have like our seal and sea lion exhibit. We monitor the temperature all the time to make sure that the water isn't too cold or too hot for the animals, and that is the same, across the zoo. We constantly monitor the temperature. Yeah.
And just another one of those factors that take into consideration. Yeah. So in addition to all of the water quality, it's also the temperature of water that we're providing these aquatic animals.
Temperature is a part of it. Yeah.
Another question about these external factors, how are your systems, your aquatic life support systems, protected if the power goes out?
We do have backup generators that are constantly get tested, minimum once a month, to make sure that they work okay. And we actually sometimes stay late after the zoo closes and stuff like that while testing the generators to make sure they are up and running, to see if the safety precautions taken of the backup systems also come up into play. So it is a constant testing to make sure that nothing fails for our species.
Great. Again, yeah, so it's operating the systems, maintaining the systems, and making sure that they don't break, because our aquatic animals' welfare depends on it. That's fantastic. We have another great question again about replicating our wild systems. Do we and how do we replicate tides at the zoo like we would see tides in the ocean?
Any exhibit that really has tides, we do actually have a tide system that I'd have to get back to you on that.
Great. Fantastic. And we had another question. Trey was wondering, how long have you been working at this job?
About 3.5 years now, which is why I don't have all the answers just yet.
That's great. Oh, and we did have an answer from Rick, our chat expert, said that we actually have artificial tide machines to recreate those tides. And I believe those tide machines also prevent the pool from freezing, so we don't have to worry about that. That's great. And, oh, we had a very specific question. Someone must have some fish tanks. Do you know how we deal with ick at the zoo? And if you can tell us what ick is.
Rick will answer that.
Rick will answer that. Great. So for those watching, ick is just an external parasite that fish can get. And really our animal care staff are, again, very well versed in being able to identify ick in our fish species and then treating it in partnership with our veterinarian staff. That's great. All right, I am looking for any final questions coming in. Great. I don't see any final questions. So do you have any final words of wisdom, Jalal, for all of our viewers watching today?
Honestly, knowing what I know now, I would say figure out what your passion is. As cliche as it sounds, if you like what you do, you will never work another day in your life. I wish this was something that I would have found out about when I was younger. And also, if you have the opportunity, take the time to volunteer, intern, to figure out if you are trying to get into a zoological type atmosphere, where you see yourself best fit. Try different avenues.
That's great. Thank you. Thank you so much, Jalal, for joining us for UnZOOsual Careers. I learned so much about aquatic life support systems and water quality and all that you do to care for our aquatic habitats at the zoo, and I know that our viewers did as well. On behalf of the Smithsonian's National Zoo and Conservation Biology Institute, we hope you have a wild day.